All right. So again, any question, guys, or clarifications up to this point? Okay, so we'll just wait 1 more minute. Maybe the others are not here yet. Forgot to include here diodes. All right. So are you guys there already?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
All right. So I like that you guys are responsive and cooperative. So thank you so much. Again, I appreciate that one. Okay. I appreciate you ng bawat instructor, lalo na hindi namin kayo nakikita. Okay, so let us now continue. So resistors, you guys already know, already know this one. This one is a basic component of when it comes to electronics. So it opposes or limit the flow of a current. Okay, simple as that. That is the role of our resistors, and this is how they look like. Well, I'm pretty sure that you guys already seen a resistor in physically or in reality. So this is how they look like. So they have a lot of different colors, or we could say bands. Okay, and each one of them represents a meaning. Okay, so this one represents the value of that resistor. So here's the usage. So let us say that you have a 9-volt battery and you want to turn on an LED light, turn on a light emitting diode, okay, or LED. So here's the connection. We have the battery right here, which is 9 volts. So you have to put here, let's say, a 350 ohm resistors before passing through the LED. Okay, why? Because 9 volts is so much for a 2 volts red LED. Okay, so what will happen if you don't have this resistor? So this will basically, there's so much current, and then this will absorb so much light, or will create so much light, and then maybe after 5 minutes or 10 minutes, this will fail, or this will get destroyed, or this will not work as an LED anymore. Okay, so that is why we have a resistor here to limit the current that will flow from our voltage source, or 9 volt. Well, it's okay if we have 2 volts right here, but in some cases, 2 volts, exactly 2 volts is not advisable. Okay, since we have a resistor that is will limit the flow of current. Okay, just by passing this wire, it already lessen the current that will pass through this LED. So maybe 2.1 or 2.2. Okay, so you can adjust it that right way, so you can have uh, a better lit, or a better light, or outcomes of your LED. And in that case, it will not create so much heat. Okay, and here are, okay, started this one. This is how to read a resistor. So we have 4 bands: first, second, third, and then the multiplier, and then the tolerance. Sorry, we only have 1 and 2, and then multiplier, and then the tolerance. If we have 5 bands, okay, or 5 color of a resistor, so it will reach up to third digit. So we even have up to 6 bands. So you can have first, second, third, and then fourth digit right here, and then the multiplier, and then the tolerance. But mostly, okay, a resistor only consists of 4 single bands, okay, or 4 color bands. So you're going to use, or you're going to read that by first digit and then second digit only, and then the multiplier next with, and then the last one is tolerance, right? So if you want to learn on how to measure a resistor, so you can always visit YouTube. Okay, so there's a 2-minute tutorial on how to read a certain resistor. Okay, and then we have here diodes. So probably you guys know what is a diode. So this one allows an electronic current to flow through them in only one direction. So for example, our current will only pass through, or will only be able to pass through from anode to cathode. So if we have an AC, okay, so once it reached the negative part, then it won't be able to pass through this anode, okay. So it will only be able to pass through if it's going from cathode to anode. So as you guys can see, this one will only allow one flow of current, or if it's positive, positive only. Okay, if it's negative, negative only. Okay, so that's how our diodes work. Okay, so they are also known as rectifiers. Okay, diodes can be used to change alternating currents, and once flowing back and forth around a circuit and constantly swapping direction into direct currents once that allows always flow in the same direction. Okay, so in your electronics, they have discussed this one. Okay, so just go back to the notes that you have on your electronics if you forget how diodes work. Okay, and then we have here capacitor, okay, which is also very useful when it comes to in every single devices that we have right now, okay, or in our appliances that we have right now. So this is one very good uh, component, okay, that will save you to cost more if you want to repair, or if there is a damage that you got to your appliances. So this one is like a battery with very low capacity. Okay, since it has a low capacity, like look like a battery, okay, or like working battery. So it charge very fast and it discharge very fast. Okay, unlike a battery, a real battery, it charge very slow and it also discharge very slow. Okay, but for a capacitor, so this will charge very fast and then this will discharge very fast also. Okay, so the main usage of a capacitor is actually to have a time delay. Okay, like for example, you have already removed the socket of your let's say TV. Okay, so after 2 seconds, that is the only time that it will totally lose all of its power. Okay, so the reason for that one is, to avoid a sudden fluctuation of going in and going out of current. Okay, so in that case, we will be able to avoid to have a damage, okay, to damage your components of your TV or any appliances. Okay, so this one is also used to remove noise. Okay, like for example, we have AC input, right? So this one can smoothen out that AC into DC, thus removing a noise. Okay, so you can say that the smoother the flow of current, the lesser the noise. The higher the a chance to fluctuate, the higher the noise. Okay, so this is where a capacitor comes to play. Okay, or making the supply voltage of a circuit more stable. Or in other words, just to make the supply or the current super stable. So that is why they call this one rectifier, because if we have this AC, we can have a smoother voltage output. Okay. So one usage of this one is a blinking light. So as you guys may all know, in the blinking light, it or electricity comes or goes in, and then after that will goes out right away. then goes in, and then will goes out right away. So there's a big chance that in the blinking light, it will be destroyed, okay, right away, or it will fail working right away. Okay? So that is why we have capacitor to smoothen out or to slow down the going in of the current and then going out of the current. Okay, and then we have here two types of capacitor. So we have the polarized and then the non-polarized or non-polar capacitor. So when we say polarized, so from the word itself, it has a polarity that you have to follow. So it has a implicit polarity, so it can only be connected one way. So you must know the polarity of a polarized capacitor. So the other one is of course non-polarized, which doesn't have a polarity, so no implicit polarity. It can be connected either way. Okay, so vice like a resistor. Okay, so the only advantage of having a polarized capacitor is one costs much less. Okay, unlike the non-polarized, this one is a little bit more expensive. So you can see that either of those two you won't go wrong. So they work the same functionalities, or yeah, there's no advantage and disadvantage. It's just the cost of of buying that component or type of capacitor. Okay, and then we have another name for this non-polarized. So sometimes they also call this one bipolar capacitors. Okay, so yeah, could be this way or that way. That's why it's called bipolar. All right. So any questions so far up to this point? The capacitor and diodes.
None, sir.
Answer.
All right.
Answer.
Okay, so let us now move on to the next one, which is the LED or light emitting diode. So to those who still didn't know that this one is actually a diode, so this one is a diode, okay, which only allows a single single flow of current. So as you guys can see, this one is polarized also, wherein you have to follow the polarity. So the longer one is the positive one, and then the shorter one is the negative one. So if you're going to put it the other way around, so it will not work. Okay, it will just simply block the current or the electricity that's flowing on that LED. So yeah, this, as you guys may all know, LED is just an indicator or for a visual feedback. We don't really use LED to use as a light, or to light up something like a flashlight. Okay, it doesn't work like that. So the main role of LEDs in our world is to use that one as visual feedback. If to check something, if there is really a current that is flowing at that point, and or just an indicator, okay, if it's turn on or turn off, okay, or you could have a cool light show circuits, okay, so you could also do that one. So here are the colors of LED. We actually have two types of LEDs. We have the single color and then the multicolor. So single color for now. See, as you guys can see, the most common color that you will see on the electronics shops is the color red. Okay, some cases we may also see green or yellow, but in some cases blue or yellow or soft white is quite rare, especially the purple one. Okay, mostly we are using red or a green one, or RGB, red, green, and then blue or yellow. Okay, so yeah, those are the types of color that we can buy on the electronic shop. And yeah, and then here's the another LED, which is the multicolor RGB or multicolor LED. So from the word itself, multicolor, it can provide many colors. Okay? So it has actually an individual color, which is the red one, the green one, and then the blue one. So you can actually combine two colors, like for example, red and green, so just lit up the red connection and then the green connection, and then no current that is flowing on the blue connection. And then the other one is of course the ground. Okay, so if you want to have a single color only, then just have a flow of current on that single connection. Like for example, red, then red only. If it's green, then green only. If it's blue, then blue only. All right, but you can have simultaneous colors like red plus green, red plus blue, or even red plus green plus blue. So it depends on the circuit. Okay. And then we have here the power types of LEDs. So this is not the one that we're talking about. We're in low power LEDs. It's just for indicator, or the one that we're calling standard LEDs, the small one. And then we have high power, wherein, of course, the more power, the more light that it will provide. So this one is the one that we are using for our, in our houses to light up something or to a certain place. So this one's like a bulb or a lamp or a light intense applications. Okay, but for the other one, it's just an indicator or indicating something. So not for actually illuminating a space or a certain area. Okay, so low power for the small LED and then high power for the bigger LED. Right. So let us now move on to the transistor. So transistor is another basic component which has three connection. We have the base, collector, and then emitter. But we will not discuss those one by one. I have prepared just in case you guys are confused on how transistor work. So I have prepared a video. Okay, so it's under module overview. And then right here, so transistors, how do they work? So this is a, I guess, 7-minute video, 6-minute video only. Okay. So in here, you will be able to fully understand how transistors really work. Okay. But for now, I'll just give you a short definition on what a transistor is. So it is actually under a semiconductor device, okay, or semiconductor electronics. So it is used to amplify and switch or work as a switch on our electronics. Okay, but the main functionality of transistor is to amplify your voltage. Okay, from maybe let's say from a microphone, it will be able to amplify that to our speaker. So that's creating a stronger or louder sound rather. Okay, and in some cases, we also use this one as switch. Okay, so you have to meet a certain call this one certain amount of electricity or certain amount of voltage for you to be able to turn on a transistor. So if it wasn't able to reach that certain electricity or voltage, then it won't be able to turn on. So that is why sometimes we use this one as a switch. Okay, so a bit of current on the base produces a current of maybe 100 times more depending on the transistor through the collector and emitter. So as you guys can see from, let's say 1 volt or 1 current or 1 ampere, it can provide 100 times more. Okay, so that is why it can amplify a certain current. Okay, so it can be used to build amplifiers full. Mostly they use transistors to build amplifier, okay, because of its usage wherein it can amplify a current or a voltage. So we have two types of transistor. We have the NPN, okay, negative, positive, negative, and then we have the PNP transistor, which is a positive, negative, positive. Okay, so in here, in NPN, so it allows electricity to pass from the collector pin to the emitter pin. So if you still don't know how transistor works, again, you can visit that one, and then they will explain where is the collector one, where is the base one, where is the emitter one. Okay, and then for the PNP resistor, so the electricity is coming from the emitter, and then will go to the collector pin. So it's the opposite of this NPN resistor. All right, but both of them serves to the same functionality wherein they can amplify and they work as a switch also. Okay, just a different flow of current. And then of course they have their own advantages and disadvantages. Right, so much with that. So let's now move on to the inductor. So you could say that this one is similar with capacitor. So both of them stores energy. Okay, so both of them protects our components from getting damaged from sudden fluctuation of the current, okay, or sudden uh, loss of the current. Okay, so since this one stores energy, then this one is like also charging, but it doesn't actually store the energy from inside of it. Okay, it's just that it has a uh, special thing which is called the magnetic field, wherein for a very short time it can store a magnetic field on this coil or in this loop wire. Okay, so that is where they are being stored. So it's not actually being stored, but they are, they keep on flowing onto this wire or electric coil. Okay. So it also stabilizes the flow of current from sudden fluctuation of the currents. It's like a capacitor. So if you have a capacitor plus an inductor, the better. Okay. The more control that you will have, or the more safer of electronic that you will have. Okay, so the usage of this one can be used in motors by creating mechanical energy from its electrical and magnetic energy. Okay, and of course there's a lot more when it comes to usage of inductor, but these are just the some. And then the next one is the potentiometer. So as you guys may all know, this one is actually a voltage divider. Okay, as you connected this one to your circuit, it is now dividing the current that is flowing to your uh, electronic components. But of course, if it can divide the current that is flowing, it can also minimize or control, or it can also allow the current that will pass through on that current. So you can say that this one is our mini controller, okay, to control the amount of current that is passing through to your current, passing through to your circuit. Okay. So commonly used to control electrical devices such as volume controls on audio equipment. So you can say that rectifiers plus potentiometer, not rectifier, uh, inductors or capacitors or transistors plus potentiometer will give you so much control. Okay, like it is already safe when it comes to sudden fluctuation, but you can still control it, but you can even control it. Not still, you can even control it with the use of potentiometer. So the safer the control, okay, of your current that is flowing through your circuit. Okay. And we have here the integrated circuit, which is the last one. Okay. So this one is actually consists of many basic electronic components. So we have a lot of types of ICs. So you can search on the internet what are their usage, but they look the same. All of them mostly look like this. Okay. So we have a lot of pins on the right side and we have a lot of pins on the left side. So trying to fit inside. So it could be an amplifier, could be a microprocessor, it could be a USB serial converter, or it could be anything. Okay, that's because we have multiple components inside wherein they are programmed to do such thing. So that is why it could be anything. That depends on the creator or who is the one who put the components inside of it, and then how they program it. Okay. So yeah, this is the last basic components that we'll discuss. And then we have a lot of other more components, okay, that you can search on the internet, but these are the basics. Okay, so if you want to learn more about basic components, then you can search more on the internet. Okay, especially if you are going to create a complicated project. Okay, so you can search more. And then here are some common integrated circuits. So we have the single circuit logic gates. Okay, so this is an IC. Oops, half others. This is another IC, full others. This is another ID, multiplexers, the multiplexers, encoders, and then decoders. So all of those are individual ICs wherein they serve different roles in our circuits. So all of them or some of them performs a logical operation like AND, okay, and then NOT. We even have We even have NAND, OR, NOR, and then exclusive OR on those circuits. Okay, so it's a combination of logical operations for them to work as half adder, full adder, and then multiplexers. And then here are the some common integrated circuits. Okay, so we have, of course, the op amps, which is very common, and then we have the 555 timers, which is also common, voltage regulators, motor controllers, microcontrollers, microprocessors, and then many more. Okay, so yeah, that's it for the basic introduction to electronics. So any questions so far, guys?
None, sir.
None, sir.
None, sir. Wala naman, sir.
Answer.
Okay, so to be honest, this one is maybe 20% only when it comes to introduction to electronics. So I would like you guys to check out more other basic components and then how they work. Okay, so yung concern lang natin dito, our only concern here is the components. So these are the things that you need to really read how they work, because that is your lab number 5. Okay, so I would like you guys to propose a simple project, okay, with the use of basic electronic components. So if you want to, include another components that you already know how it works, then no problem. Just let me know that you're going to use this component and etc. etc. Okay, and then of course you have to define why you chose or decided to propose that project. So what is its importance in our society? Okay, so not just a project, it must have a significance in our society or in our daily lives. Okay, so not just a nonsense project. Okay, should be an important or a useful, okay, not really important, should be a useful project. Okay, so you can use FreeSync to create your sample layout. Again, you can search for other basic components that you can look onto our FreeSync. Of course, I'm pretty sure that you can find that components if ever you have found new components that we wasn't able to discuss on this module. All right, so for now, I would like you guys to propose a simple project, okay? Not a complicated project, but just a simple project, okay? And then what its usage and what is the importance of it in our society or or around us, okay? Chose lang. Right, so yeah, that's it for the module 3. So are we clear so far regarding with your lab number 5?
Yes, sir.
Or can I use actual circuit?
Yeah, you can use an actual circuit, especially if you have the breadboard, the connecting wires, have the battery, resistors, etc.
Okay, sir.
Okay, so you can test that one out first, maybe in actual, and then before creating that one on the FreeSync. Okay, so any other questions or concerns? Okay, so according from Mr. Jason Romer Averia, so he have already used FreeSync before. Okay, so FreeSync is doesn't seem to be user friendly. Really, for me, it seems to be friendly than the other applications that you can create, or you can experiment using breadboard. Anyway, I hope that this tutorial will be able to help you, on how to create a simple project. Okay, so when it comes to routing the wire that you will see on the actual project on how to put them on the actual PCB, So that is not a requirement for now. So that will be on finals. Used to it because in my previous subject as to use Proteus. So yeah, that is another application. So you guys can use another application if you guys want. Okay. So what important is I would be able to see the virtual schematic diagram of your project. Okay, so you can use Proteus, you can use any other applications you can find on the internet. All right, so anyway, so this is the last one already. So now that you have learned the basics and fundamentals of electronics, so we could say that all the components that we have discussed has a very important role in every circuit. So the question here is, now you will be given a chance to choose only 3 components from what we have discussed logically. So what are those 3 components and why? Like why capacitor, why resistor, why inductor, okay, why not a diode, and so on and so forth. Okay. So what do you guys think is the importance of this one rather than choosing this component? Okay. So yeah, just a simple scenario and simple question. So, any questions or concerns?
None, sir.
No, sir.
That I have
Wala
missed?
po, sir.
None at the moment.
None for now. Okay. So I highly suggest or advise you guys to watch the video materials. So yeah, there are other links in the YouTube that you can find, but I guess these are the most helpful one. Okay, so I've watched most of them. Okay, and then I've chose the most easy to understand, and then the most maybe most good definition or easy to understand definition. So yeah, pang beginner kumbaga. So the others are quite techy already or very technical, but for these 6 links, they are super friendly for beginners. So you'll be able to understand this one right away. Okay, and then you can also download those 3 PDFs if you want. Okay, so they are very, very helpful when it comes to understanding the basic electronics or the introduction to electronics. Okay, so let me just show this one to you guys. So we have here the PDF, which is the basic electronics, where it will talk about semiconductors, the type of silicons, what is a diode, how does it work, and how it doesn't work, some applications of diodes, and then how a transistor works, etc., etc. Okay, so they are very useful. Yeah, and then the another one here is more on concepts of electronics. So you actually have a lot. Yeah, so it will give you on how to compute, etc., and then it will give you a schematic diagram on what will be the voltage input, voltage output, the gain, the current, etc., decibels, wattage, inductance, capacitance, and so on and so forth. All right. So yeah, I guess that's it for today's meeting. So if you guys do not have a question anymore, then you guys may now go and then have a happy lunch. So thank you guys for coming. So I really appreciate it. So see you guys next meeting, or probably not. I'm not really sure. So because for today, will only be the